so we're going to be factoring polynomials. So one of the things that we need to remember is that when we were doing synthetic division or long division, if we ended up with 0 for our remainder, okay, that had a real meaning to it, because then it was basically then your answer was a whole number, right? Okay, when you think about it. Okay, but your answer was a polynomial then without a fraction on the end. Well, what that means then is when we did that, the result we got, if it equals 0, okay, then that means that what we divided by was actually a factor. And so we're checking to see if we get factors, first of all, and if whenever we divide and we end up with 0 as our remainder, that tells me that whatever I divided by was a factor of the dividend. So if we ever put that value for a in for x, find the answer. If it equals 0, it's a factor. In other words, when you're graphing, that would look like when the graph crosses the x-axis, wherever those zeros are, means that when I use that as a divisor, then I have an actual factor then. So we have what's called the factor theorem. For any polynomial, p of x, x minus a is a factor of p of x if and only if p of a equals 0. So if we get 0 when we divide, then we know that x minus a is going to be a factor. So let's do letter A here. So all I need to do is a little bit of synthetic division. My 0 here for the x plus 1 would be negative 1. So I'm using the 0 and checking to see by using synthetic division or synthetic substitution to see if I end up with 0. If I do, it's a factor. If I don't, then it's not. So we bring down our 1. Negative 1 times 1 is negative 1, so we get negative 4 when I combine them. Negative 1 times negative 4 is 4. Add them together, and we get 5. So since this number here is not equal to 0, then x plus 1 is not a factor. Problem's right. Since 5 is not equal to 0, then x plus 1 is not a factor. Now, if we have a case like this example here, which was number 3, it's very similar. The only thing is it says 2x minus 4. Well, as our factor that we're looking at, and we talked about, we said when we use synthetic division, you can't do that one because of the 2 in front of the x, right? Okay. It doesn't work with the synthetic division for dividing, but I can still use the 0 to see if it's a factor. So that means the first thing we've got to do then is set 2x minus 4 equal to 0. So we find the 0. Then I can plug that in using synthetic substitution to see if it is a factor or not. So in this case, we would get x equals 2 as our 0. And so we'll use 2 then to see if I get 0 using synthetic substitution. If I do, then it is a factor. So let's see if we're missing anything. No, we're missing the cube. So we got to make sure we put a 0 in there for the cube term. cubed for my 0 term instead of 0. So bring down the 2. 2 times 2 is 4. Oh, that's nice. That's equal to 0. 2 times 0 is 0. We're still at 0. 2 times 0 is 0. Bring down the 2. 2 plus 0 is 2. 2 times 2 is positive 4. So we have negative 2 plus positive 4, we get positive 2. And then 2 times 2 is 4 again, and we get 0. So since this is 0, that means then that 2x minus 4 is a factor of this polynomial. So even though it has a coefficient of x here with a 2, if I'm checking to see if it's a factor, then I just need to find the 0, use the 0 then in synthetic substitution. If my remainder is 0, it's a factor. If it's not, then it isn't. The only thing is that we can't use it to divide. Okay? What actually happens if I was using it to divide, then I would have to take all of these numbers here, all these numbers here, and divide them by 2 for the division part then. You talking about here? Okay, yep. When we solved it, we said equal to 0 and solved it, so we got positive 2. And so that's the number that goes in there. Okay, we want to know when it equals 0. And whenever this part equals 0, that's the number I'm using for in the synthetic substitution. Sometimes they tell us the number, sometimes we have to find it out. Okay, so we're going to factor by grouping. Okay? So whenever we have 4 terms, okay, and the leading term, if there's 4 terms, well, let me not say that. If there's 4 terms and they decrease in degree by 1 each time, then you can try to factor by grouping. Okay? When we talk about factoring by grouping, what we mean is we're going to take the first 2 terms and we're going to find the greatest common factor of them, and then take the last 2 terms and find the greatest common factor of them. Okay? So factoring by grouping, find the greatest common factor of the first 2 terms and then the last 2 terms. Okay? So if we look at the first 2 terms, 8x cubed plus 4x squared, what do they have in common? 4x squared. So I take out 4x squared, and then what do I have left? 2x plus 1. Okay. Right. Now we take the next 2 terms, and we want to factor the greatest common factor out of them. So what's the greatest common factor of negative 2x minus 1? Negative 1. Okay. So if I take out that negative 1, what do I have left? 2x plus 1. Okay? And here's the thing. Our goal is to get these 2 things to be the same. Okay? If they're the same, then factoring by grouping works. If they're not the same, then you can't factor by grouping. Okay? So one other thing is that whenever this third term is negative, if the third term is negative, then you have to factor the negative out. situations like that a little bit later, but you've got to factor the negative if the third term is ever negative. Okay? So now if we look at these, okay, I have underlined in yellow those two 2x plus 1s. Well, the 2x plus 1 then, they are greatest common factors. Because if we look at this whole part right here and this whole part right here, we have two terms here, don't we? Okay. Well, those two terms have a common factor now, don't they? They both have 2x plus 1. So that means then I can factor out 2x plus 1 from both of them, and I'm left with 4x squared minus 1. So basically, we did the GCF twice. Okay? Did the greatest common factor for the first two terms and then the last two terms. And then we took out the greatest common factor of our results. Okay? Now, we have 4x squared minus 1. It's a quadratic. Can I factor it? And the answer is yes, because it is the difference of two squares. So for our result, we have 2x plus 1. And then we have the difference of two squares here in this 4x squared minus 1. We have 2x that's squared to get to 4x squared, and 1 that's squared to get 1. So my answer would be 2x plus 1 times 2x plus 1 times 2x minus 1. And you could write this squared if you wanted to. What's that? You didn't know what to do here. Okay? At this junction here because of the difference of two squares of the 4x squared minus 1. Yep. Okay. So let's look at another example. Example 2 here. Okay. It says factor x cubed minus x squared minus 25x plus 25. So we look at it. There are four terms in descending order, okay, by 1. So we'll take the first two terms and the last two terms, and we'll factor them. And I'm going to show you what will happen if we don't take out the negative. Okay? So the first two terms both have x squared in common. I'm left with x minus 1. And the last two terms have 25 in common. So if all I did is take out 25, then I would be left with, oh, this is a negative x plus 1 then, isn't it? Well, then are these two the same? Okay. Well, this one has a positive x and a negative 1, and this other one has a negative x and a positive 1. They're not the same. Okay. So I don't have a greatest common factor with those two then. I would be done. I couldn't go any further. Okay. So that's why it's important that you always, if the third term is negative, this term is negative, then you've got to factor that out. You've got to use the negative with it. So if we do that, we have to take out the negative 25. That means then the x is positive and the 1 is negative. And now I do have those two are the same. So I take out that greatest common factor of x minus 1 again. And then we're left with x squared minus 25. Which is what, Lauren? It's the difference of two squares. So it would be x plus 5 times x minus 5. could I factor it if it was x squared plus 25? Jasmine's shaking her head no. Why not, Jasmine? Okay, you just know you can't, right? All right. Well, I'm going to show you why. You got your calculators? Take out your calculator. If you got it, and I'll show you why you can't. Let's see, find my calculator here. Oh, I didn't need to do that. Show you why. Okay, so if we go in our y squared, or in our y equals, and we put in, and let's use a smaller number. Let's use 9. X squared minus 9. Okay? And then x squared plus 9. Okay? Now, if this was factorable, that means that there are going to be zeros, right? Because if this was factorable, which means I would have a 0 since this one, if it's factorable, I will have zeros. Since this one is factorable, I have zeros at positive 5 and at negative 5. Right? So, but we're going to look at it using x squared plus 9 and x squared minus 9. Right? Because 9 is a square, right? It's 3 squared. So for this one here, I'm going to have a zeros at plus 3 and negative 3. Okay, plus or minus 3. So let's see what the graph looks like. All right. So we have zeros at plus or minus 3. Okay. Let's see which graph that is. So if I hit trace, then that's graph is x squared minus 9. It has a 0 at 3 and a 0 at negative 3. Now our other graph, if we change graphs then, the other graph is up here, okay, at the top of the screen. Are there any zeros there? No. Okay. The one way I know things are factorable is if they have a 0, then they can be factored. Okay. If there are no zeros, they can't be factored. So anytime we have x squared plus a number, okay, positive x squared plus a number, that takes the graph of x squared and it shifts it up, which means there are no zeros then, and you can't factor it. Okay? If it's x squared minus some number, okay, then that can be factored. So how about if you do one more practice problem with these, then okay. Well, not only do we have difference of two squares, but we also have what's called the sum and difference of two cubes. And here are the formulas for factoring the sum of two cubes and difference of two cubes. And this is something you're definitely going to want to put on that wonderful little piece of cardboard that you have, okay, called a note card. So the sum of two cubes says if I have a cubed plus b cubed, that's factored into the quantity a plus b, so the two things that are cubed, times the quantity of a squared minus ab plus b squared. The difference of two cubes, a cubed minus b cubed, says when I factor that, I get the quantity a minus b times the quantity a squared plus ab plus b squared. So notice, when it's the sum of two cubes, it's a plus b, and the sign between a squared and ab is negative. When it's a cubed minus b cubed, a minus b, and then the sign between a squared and ab is positive. Okay, so there's some connections there. And it would be good for you to memorize those formulas too. Okay? Not just write them on your note card, but to actually memorize them so that you can use them quickly. All right, so letter A, we're going to factor 4x to the fourth plus 108x. Now, one of the things to remember is whenever we're factoring, the first thing you should always look for, okay, we don't talk about this enough, but the first thing we should always look for is, do they have something in common? Is there a greatest common factor for all of them? So 4x to the fourth and 108x, do they have a common factor? 4, anything else? X, okay? So they both have a 4 and an x, so we're going to take out 4x first of all. And we're left with x cubed plus, what? 27. Now, this reminds me of something that I want to do. Okay? So I'm going to add a page here. And off to the side on that page or somewhere where you can access it very easily, maybe it's the front of your notebook or whatever, we're going to make a little table. Okay? And we're going to make a table that has squares and cubes. Okay? And let's see. I actually want more than that, so I'm going to do that. Okay? So we're going to take the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And we're going to write down the squares and the cubes. We won't go all the way to 12 of the cubes, but so you need to write down the squares and cubes for all of them. 1 squared is 1, 2 squared is 4, 9, 16, 25. Because these are numbers that when we're talking about difference of two squares and difference of two cubes, numbers that are going to come up quite often, and it's important that you can recognize them right away as being a square or a cube. So let's do the cubes. Okay, 1 cubed is 1. Okay. 2 cubed is, it's 2 to the third power. 8. Okay. 3 cubed, 27. 4 cubed is 4. Okay. How about 5 cubed? 125. And 6, 216. Now you could just go to your y equals and put x cubed in your y equals 2, couldn't you? And then look at the table. Okay. How about 7? What is it? 343. Okay, and then we'll do 8 and we'll stop there. Well, no, we'll go all the way to 10. So what's 8? 512. Okay, and 9 cubed is 729. Hopefully we all know what 10 cubed is, right? Okay, add a couple zeros and get 1,000. Okay. We won't get to them. You won't ever need to get to 11 and 12 as far as I can remember. So, okay. Now, it's important to have these somewhere where you can easily access them, because when we're solving problems then to where it's the sum or difference of two cubes, I need to be able to recognize, is this number here, 27, is that a cube? Okay? And if I have easy access to a sheet with the cubes on it, I can find it really quickly. So is 27 a cube? Yes, it's 3 to the third power. So I have the sum of two cubes here, where A would be equal to x, and B would be equal to what? What's cubed to make 27? 3. So what we're saying is that this is 4x times x to the third power plus 3 to the third power, right? So I have two different things that are being cubed, and I'm adding. So I have x that's being cubed and 3 that's being cubed. So I would say I have 4x, and then I use so then I'm going to use the sum of two cubes. So I'm going to put in x where there's an a, and put in 3 where there's a b. Yep. Right. The power of x. Okay, whatever the powers are. All right. So here we're going to have a plus b, so x plus 3 is our first term. Okay. And then we got a squared, which is x squared. Then it says minus a times b, which means we're just going to multiply x and 3 together, so 3x. And then we said plus b squared, which is 9. And so then that would be my answer. And you cannot factor the x squared minus 3x plus 9. You don't ever have to worry about that. Okay? If it's a cube, then this part here, okay, cannot be factored. Okay, so let's look at another one. $125 d cubed minus 8. So first we look to see, do they have anything in common? Do 8 and 125 have anything in common? Okay. Okay. They don't. Right. Now the big thing I'm looking at here is the fact that it has d cubed. So this might be the difference, because it's a minus sign, the difference of two cubes. Well, is 125 a cube? Okay, that's 5 to the third power. Okay, what about 8? Is it a cube? Yes, it's 2 to the third power. Okay, so I have to establish then, I need to figure out. So we have a cubed minus b cubed in this situation. I need to determine what is A and what is B then, so I can fill it in. All right, so what's being cubed here and here? What's cubed to make 125d to the third power? You know? What cubed is 125? 5. And what cubed makes d to the third power? D. Okay. So 5d is cubed here, and 2 is cubed there, which would mean that our values of a and b are 5d and 2. So then we just need to plug them into the difference of 2 cubed formula. So we have 5d minus 2, a minus b. Then it says we square a. So 5d times 5d would be what? 25d squared. And then it says there's a plus sign. And I multiply a and b together. Okay? 5d times 2 is 10d. Then I put a plus sign. And then it says to square b. So if we square 2, we get 4. So there's our answer. So we have to establish what a and b are. Okay? Is it the sum of 2 cubes? Is it the difference of 2 cubes? Well, that's easy if it's a plus or minus. Okay? Then figure out what a and b are, and then just plug them into whichever of the 2 formulas you have. Okay. You can also use graphs to help you factor. Anybody ever use a graph to help them factor? Okay. You can use them because if I know the zeros, then I can write it in factored form. So here we have this. It says the volume of a plastic storage box is modeled by this function. So I identify the values of x for which it's equal to 0, then use the graph to factor it. Okay. So first, let's graph it and see what it looks like graphically. So we've got, here are these other graphs, x cubed plus 6x squared plus 3x plus 10. Oops, minus 10. All right, so this has 3 zeros, doesn't it? Okay, so v of x equals 0 when x equals, let's see what we got, negative 1, 2, 3, 4, 5. So negative 5, negative 2, positive 1. Now, do you remember when we were solving quadratic equations by factoring, we were looking at finding the zeros, right? So if you remember, let's take an example here. And that if I said that I had x squared minus 6x plus 8. If I want to solve this equation, right? Solve it by factoring. So if I factor this, what would I get? Okay, 4 and 2, right? So we would have x minus 4 and x minus 2 equals 0. So if we're solving this equation, then what would be my answers for x? Okay, 4 and 2. Does everybody remember that? Lauren, you remember that? Okay. So notice, these two zeros I have, 4 and 2, are positive. When I write it in factored form, they are negative. They're the opposites. Okay? So if this gives me zeros of negative 5, negative 2, and 1, then I can say that v of x equals x plus 5, x plus 2, and x minus 1. If we know the zeros, to write it in factored form, the factors are going to be the opposites. Which is one of the things we were actually talking about with when we were doing synthetic division, right? We said, okay, we're going to divide by x minus a. Right? So what did I put in there? Instead of negative a, I put positive a in there to find out what the value was. Okay, so if you know the zeros, you can factor. So here's the thing. If we go back here, right, to this factoring by grouping, what do you think would happen if I graph this? Oh, that was kind of a tough one. Let's not do that one. Let's talk about this one here. Okay. All right. So if I graph this one right here, this function, okay, what would the zeros be? Okay, 1, negative 5, and 5, right? This would give me a positive 1 for a 0. This would give me a negative 5 for a 0. And this would give me a positive 5 for a 0. So if I wrote them in factored form then, I would have x minus 1, x plus 5, and x minus 5. Okay? The opposites. Okay? You guys remember that then?